Hello, Facebook. I'm Evan Deshevsky, features editor with PCMag.com. Welcome to The Convo. Now, this is the Facebook Live series where we talk to the boldest mind in technology, science, and geekdom. And today we're going to talk about space. Now, sure, space is filled with the promise of exploration and all that wonderful stuff, but it's also filled with the promise of money. Okay, so one of the most ambitious for-profit companies looking at space profit is Planetary Resources, which aims to be the first company to mine near-Earth asteroids for raw materials. Whoa. Okay, there's potentially billions, if not trillions of dollars of resources just floating around out there, not so far from Earth, and is ripe for the picking. Now, but before Planetary Resources gets to that, they're embarking on some smaller projects, baby steps. Okay, so one of those projects is the Ceres project, which will rent out the company's soon-to-be-launched array of mini prospecting satellites for use here on Earth. So let's roll a clip to see what we're talking about. Whoa, pretty cool, right? Okay, so that's why I'm so happy to introduce today's guest, Chris Lewicki, the president and CEO of Planetary Resources. Chris, welcome to the Convo.
Hi, Evan. Hi, fellow geeks. Happy to be with you here today.
Great to have you. So you're an asteroid prospector.
Absolutely. Why not? The world is moving forward at a pace which I don't think anyone quite predicted. Mm-hmm. And there's so many things that we have learned about our universe, our solar system, and our own planet. And we actually have the technology now to go out and do something about that. So that's what Planetary Resources is doing, starting with building the technology that will help us figure out where those valuable things are and what to do next.
Oh, I should also mention for you guys at home, and guys and girls, drop your comments in the comment section. Social Pete will read them off later in the show. Okay, so you gave a brief description of what Planetary Resources does, but why mine in space? Like, what kind of materials are you going after in particular?
Well, we're mining in space because we're going to be in space. Mm-hmm. We're seeing a lot of development from folks like SpaceX and Blue Origin and Bigelow Aerospace and others. And space is more and more becoming a part of our daily lives. Mm-hmm. And the goal of Planetary Resources is to have things that you need when you get into space. Mm-hmm. These are things like water, which is very important to us, sure. Very expensive to ship. Mm-hmm. Stuff like oxygen, so that you have something to breathe, which of course is part of water, and to have fuel for your spaceship so that when you get to the end of your journey, you can top off the tank and continue on your way. Mm-hmm. Other things that are important are things like the construction materials. I've got in my hand here a piece of an iron meteorite.
Wow.
And this is the future construction-grade stainless steel that we're going to use in space to build future habitats, future vessels to travel in, probably even future sources of energy. Mm-hmm. And all this material is out there, and just like when we arrived in the corners of Earth centuries ago, we used local materials to make our lives and livelihoods. We're going to do the same thing when we get into space.
Now, do you want to bring any of these materials back for use on the surface of Earth, or do you think you're mostly going to be for the future space industry?
The vast majority of what we're developing will be for use in space. Mm-hmm. But there are a few things in space that are so useful and currently so valuable that in the perfection of the industry, when we're really good at it, we may bring things like the 6 platinum group metals back to the surface of the Earth. And it seems like something today it's kind of hard to comprehend of, making platinum as common as aluminum. But aluminum, as it was 150 years ago, actually used to be as rare as gold. Mm-hmm. And there's a lot of interesting anecdotes in history about how we, to show our technological achievement, when we finished the Washington Monument in Washington, D.C., we capped it with a pyramid of pure aluminum, which today seems kind of absurd. Yeah. Napoleon used to serve people in his king's and queen's court on dinnerware made of pure aluminum, which was the decadence and opulent of the time. But of course, today, you wrap your burritos in it, your computer, your phone's made of it, you're shooting in a chair made of it, electricity is delivered to your home and your business in it, and you fly through the air with tubes of aluminum, and it's transformed our society, and developing resources in space has the opportunity to do that all over again.
For anyone just joining us, drop your questions about space, about mining, about all this kind of cool future stuff we're going to talk about, and Social Pete will talk about it later in the show. And we already have a question. Pete, what you got?
We have someone just with a general question. Why do we need to bring these resources from outer space?
Well, you kind of jumped into this already, but what's your best argument for why we need to mine space?
Yeah, let's talk about actually why we need these resources to develop the economy in space. Everyone, I think, is familiar with rockets and has seen a rocket launch. And there's a reason why they call it rocket science. It's because it's really hard. And we have machines that are operating at the edge of their performance, and they're doing that just to barely escape the bonds of gravity from Earth and deliver a very, very precious and expensive payload to Earth orbit. And to send anything much farther than that gets much more expensive, much more challenging, and you get to things like we saw during the Apollo program, where you have a little tiny, tiny capsule on top of a giant, giant rocket. So one example, and this was something that Elon Musk actually revealed just recently, is their plan in going to Mars involves refueling their spacecraft in orbit. And that's because you can get a much, much bigger spacecraft to orbit if it's not full of fuel. So you can fill those empty tanks up in low Earth orbit. And at first, we're going to probably start filling those tanks with material that we also launch up. But over time, you can bring that material in from space and source that oxygen and hydrogen and methane from places that are easier to get it from than launching it up from the surface of the Earth.
So let's talk about Planetary Resources, short-term, long-term sort of plans. So you guys want to put up an array of kind of mini satellites to prospect near-Earth objects for what kind of resources they have within them, and then further down the line, you actually want to send ships there to exploit those resources. Also, is that correct? And what kind of timeline are you looking at for all this?
Well, we've developed the Arctic 200 satellite, which is over my shoulder here in the picture. Arctic 200 satellite is the 21st century prospector. This is a satellite that will use very advanced and unique sensors to go out to a near-Earth asteroid by 2020 to a carbonaceous asteroid and find water resources on it. This is H2O. Everyone knows that molecule. The oxygen, of course, is used, the hydrogen is rocket fuel. And these are things that are, as we've described, are very important in exploring space. And what we're doing right now, over my other shoulder, is testing this technology out in Earth orbit with our Arctic 6 satellite. We have 2 of these built in our clean rooms here in Redmond, Washington, built by our team of 50 very talented engineers. And we'll send these up to space and start to try out the technology. And before we take them all the way out to an asteroid, we're actually going to point them at our own planet and use the thermographic sensors and the hyperspectral sensors to measure and monitor resources on planet Earth, which, as you imagine, are very important to us today as we develop those resources out in deep space on the near-Earth asteroids.
Just to reiterate, so this satellite here, this one kind of looks like a donut, that satellite or one like it will actually be going to an asteroid in 4 years?
Absolutely, and actually, both of these are full size. These satellites are small enough to fit in my office. The Arctic 6 satellite will actually fit underneath the seat in front of you or in the overhead above on an airplane. And this is something really that's possible today with technology that's been developed not only in the aerospace industry and by NASA and ESA and the other space agencies of the world, but the billions and billions and billions of dollars that have gone into developing your cell phone, your tablet, your laptop, or the cloud data center that supports your online activities. All of these are technologies which we actually can now take from the consumer world and launch them into space.
This is fascinating stuff. Facebook, I see you have a question.
That's someone who asks, what kind of robots would you need for this operation? What would you need for them to do?
So the prospecting satellites, like the Arctic 200, in a lot of ways are doing the same thing that NASA satellites of the 1960s did. The Mariners, the lunar orbiters, that fly by planets or orbit them and take relatively simple measurements. We're not trying to figure out why we are all here or how old the solar system is or how we came to be. We're answering a very simple business question. Is there enough water on this asteroid for us to go back? And our first mission with the Arcad 200, actually a small cluster or swarm of these satellites, will collaboratively explore an asteroid to answer that question. Once we've found a good asteroid, and we think that actually is possible on the very first trip, because we can use what we know from pieces of asteroids that are delivered to the Earth in meteorites. We can use telescopes on top of mountaintops to take remote measurements, and of course, our governments are still continuing to reveal lots of exciting insights about asteroids. So odds are good that the first one we go to should be a good place to continue. Now we'll have a workhorse of a platform that we can use to deliver the experiments and tools on how to extract water from an asteroid. And I'd like everyone to know that this isn't necessarily going to be Star Trek super advanced 24th century technology that's going to look like the most exotic thing you've ever seen. We actually built, the United States using the iron horse by burning wood in a steam engine on steel rails that went across the nation. And of course, there was a lot better technology that could have been done to do that. But as we begin developing resources on asteroid, we'll start very simply. We'll use the resources on the sun to heat up the asteroid. We'll turn the water into a vapor, and we'll use the vacuum in space to transport that vapor. And we'll use what is the cryogenic cooling chamber of space. Everything that's not the sun in space is very, very cold. And we'll use that refrigerator, so to speak, to condense that water back out into pure ice, which will then transport back to proximity here at Earth. And everything that I just described is something that is actually completely free. All of the energy, all of the cooling, all of the vacuum just exists naturally in space. So things that we would pay a lot of money and a lot of energy for on an Earth mining business actually just come along for the ride in space.
Very cool. Facebook, I see you have a question.
Planetary Resources has no doubt learned an enormous amount from publicly funded research. Does the company have any plans to make discoveries and data available to researchers for free?
Yeah, certainly. And it has been the benefit of more than 50 years of publicly funded space exploration and research development that makes companies like ours possible. I myself actually worked with NASA for 10 years when I was a system engineer and flight director for the Spirit and Opportunity Mars rovers, and then service mission manager for the Phoenix Mars lander, which dug up water near the Martian pole. We have a lot of scientists and engineers on our team, kind of with similar backgrounds and experiments. And I think a lot of the data that we collect about these asteroids, much in the way that the mining industry and the oil and gas industry has led to new insights in geology, I think data that we will create and discover and share with the world about near-Earth asteroids is going to further planetary science. And we think that making data available that we collect to the broader public to have the best research and scientist institutions in the world help us learn how to grow out this industry is an important part of our business plan.
Now, let's talk about something a little closer down to earth. Now, last year, U.S. Congress passed a bill saying that companies are allowed to exploit asteroids in space and have a business built around that. But also, just what are the legal ramifications? Can you claim an asteroid if another company, if Mark Zuckerberg wants to start a company to claim an asteroid that you guys already have your sights on? Are you guys going to have to go to a space war, perhaps a Star War, over this sort of thing? I mean, what are your thoughts on this? Or is there any legal ramifications for these sort of things?
Yeah, it's a great question and a question that a lot of people have. Yeah. And this is something, as you mentioned, the United States passed into U.S. law, the Commercial Space Launch Competitive Act, last fall. And this actually helped set a very basic framework to answer exactly this question. And this law says a few very simple things. It says that when you go out in space and you obtain a material from a near-Earth asteroid or for somewhere else, that material that you obtain is yours. It says that you have a freedom from being interfered with while you're doing that. Kind of like if I have a private property and I put up a fence, you can't interfere with me on my private property. So it sets up a framework for doing that. But of course, a lot of this is quite literally new territory.
Yeah.
So this is just the beginning, and this kind of sets in motion a lot of exciting developments, both for the United States and for the rest of the world, to sort these issues out, as we're doing with other new industries. With new things we're seeing in medicine and the internet and commerce and electric cars and self-driving cars. All of this new technology is creating new challenges for what essentially is 20th century law and policy, and we're very happy to have the leadership of the United States behind this, and we're also very excited to see other countries and agencies in the world, whether it's new space agencies in the Middle East, like the United Arab Emirates, talking about their interest in adapting similar policies, or leadership of small but very influential and innovative countries like Luxembourg, who has recently announced a 200 million euro initiative to help start the space resource industry. And Planetary Resources is very excited to be in talks with them for a 25 million euro package to help further our business and to accelerate our progress.
Well, speaking of business, so about 2 years ago, I interviewed Peter Diamandis, one of the founders and chairman of Planetary Resources. So I was talking, he had a book out at the time, but I was asking him about Planetary Resources. How does a company that has goals for decades down the line, how do you, keep that going and keep the, the overhead paid for and all that? And he admonished me, saying that, no, Planetary Resources is making a profit right now. So I don't know, what is the business plan? How do you pay for your office and all the employees when the big goal, at least, is further down the line?
Yes, well, you start an asteroid mining company with the support of a lot of very visionary people, folks like Larry Page and Eric Schmidt of Google, Charles Simonyi of Microsoft, Richard Branson and others. Yeah. And, they have the vision, and of course, as everyone realizes, I think they have the capacity to take some risk in their business ventures. Yeah. But it was clear to us, and it certainly was their demand, that we create a business, not just something that is going to be spending money for a very long time. We realized that we had to create a lot of very disruptive new technologies to be able to grow this business and ultimately to prospect and mine asteroids. And that's what we've been working on every year since our founding. And Peter is right. We actually have been a profitable company generating revenue based on the technology and the capabilities that we've assembled in our team here in Redmond, Washington. We're currently under contracts to NASA. We've worked for private industry. We've worked for Fortune 500 companies. We've done work for the Defense Department. And we are now doing work in consumer markets, including things like global precision agriculture, where we're helping to manage and monitor resources on our own planet. So our own strategy is, looking out to that moonshot or that space shot of asteroids, understanding every step of the way the roadmap that we need to get there, and really aligning and running our business so that we can take the hyperspectral sensors and the thermographic sensors and the advanced computing technology that we've put on our satellite, and we can deploy that to a business opportunity and a demand in a market that exists right now.
Facebook, you have a question.
We had a commenter who was saying they'd love to work for Planetary Resources. I guess what kind of background do you look for this company?
Yes, well, that gives me an excellent opportunity to tell everyone to go to planetaryresources.com and go to the careers page. We have a number of job postings we're looking for. Sometimes they can be quite technical, whether you're a guidance and control engineer, a power system engineer, system engineer, hyperspectral imaging scientist, or embedded computing. A lot of things like that are very technical sounding, but we also have economists working for the company. We have business majors. We have geologists. We have all sorts of disciplines. And now with setting up international operations in Europe, we're going to have an opportunity for people all over the world to join Planetary Resources, and we'll be announcing some new positions available there. We also have a lot of students working for us, and I myself was the benefit of internship programs with companies and with NASA, and we like to pay that forward and give the opportunity to both give people from college that experience, but I'll be honest, some of our best sources of new hires are people who are interning with us, and we're actually recruiting our next class of interns who will join us in January. And this is also something where we don't do your typical summer internship of shoving you in a corner and asking you to go get the real engineer's coffee. We ask you to join our team for 10 months, take a semester off college. We give you real work, which we expect you to do well, and your product is going to end up in space. So it's a very challenging environment and also a wonderful opportunity to really help shape the future of commercial space. Mm-hmm. So, with that, I would say the last thing that I would suggest to people is you do have to be extraordinary. You have to be very passionate. Mm-hmm. And, good grades are a wonderful thing, and degrees are nice as well. But we really want to see that you have a demonstrated track record of working with others, of doing cool projects and making things happen. And that's what we look for most.
Very cool. Facebook, you have a question?
Just to kind of recap too, what other resources besides water are you really trying to find? Someone asked about helium.
So there are, everything that we enjoy here on Earth is in limitless quantities in space. Mm-hmm. And to paraphrase Douglas Adams from The Hitchhiker's Guide to the Galaxy, it's mind-bogglingly huge. You really just can't even imagine how much resources are out there. It makes the Earth look like a pittance. Mm-hmm. But, we can't start with the entire periodic table of the elements. So as we had mentioned, we're starting what we see as the keystone for taking humanity into space, which is plain old simple water and all the things that water enables to do. Mm-hmm. Not only is it a fuel source, not only is it something that helps us breathe, not only is it something that we enjoy as part of our food supply, but we often don't think of the role of water in our daily lives in terms of hygiene, and even manufacturing and being able to use it as a cooling agent or as a transport agent. And in space, in addition to being a fuel source for rocket propulsion, water takes on one other very important role in that once you get out of the Earth's magnetosphere and our atmosphere, you get subjected, unfortunately, to some pretty harsh space radiation. Mm-hmm. Some of it's coming from our own sun, but some of it's coming from the cosmos, cosmic background radiation from supernovas and exploding stars. Mm-hmm. And this is one of the biggest hazards that we have in journeys to Mars is not getting cancer along the way, mm-hmm. As our cells are subjected to all this. Mm-hmm. But the good news is water, actually, as it turns out, is an excellent way to protect you from that radiation. Mm-hmm. And it's the reason why at a nuclear power plant, when you see them storing the nuclear fuel, it's stored at the bottom of a pool, because that pool actually completely blocks all that radiation and keeps it from being transmitted to you. So a few feet of water between you and the universe actually can keep your human biology ticking along just fine. So, that's where it all starts. As I'd mentioned, things like iron and nickel and cobalt. This is the Iron Age of the 21st century. Mm-hmm. And we had a fun piece we did earlier in this year. I'll actually ask one person on my team to go get a little element that we actually 3D printed. Yep. One of the first objects ever from an asteroid, and I'll show you that in just a minute. Mm-hmm. But think about space manufacturing and being able to build things on site, being able to build kind of porous structures that don't have to be solid, that don't have to survive that journey into space with all the violent shaking and acceleration, and don't have to hold their own weight, and we don't have to fold them up to fit inside a rocket. So manufacturing in space and how we get things into space will completely transform when we can build things on site with 3D printers. And think about the International Space Station. It's this Lego block set of things which look like a tube that fit into a rocket fairing or the now retired space shuttle payload bay. Mm-hmm. And imagine if we could build whatever we want, any size that we want, and we could send it anywhere we need. And that's what being able to use the iron, nickel, and cobalt from asteroids allow us to do. Mm-hmm. And as I had mentioned, the platinum group metals, platinum, iridium, ruthenium, osmium, some of the densest, some of the most valuable catalysts that we have on the periodic table are abundant in space. And now, instead of worried about the price tag for what platinum is, we can focus on really just using the best material for the job. And coming here off screen, I'll bring it up. We unveiled this little piece at the Consumer Electronics Show earlier this year.
Oh, very cool.
This is the world's first object printed from extraterrestrial materials, taken from an iron-nickel asteroid. And actually, right next to me is the very meteorite. We cut off the top half of this. You can see one of it's being lopped off.
Yeah.
And we printed this little spaceship. So this is what is made possible by technologies like 3D printing, by technologies like automation and self-driving cars. Asteroid mining sounds like about one of the most futuristic things that you can be working on.
Sure.
But, 150 years ago, so did things that would fly through the air like birds. And we clearly have conquered that with technology, and we'll do the same with space, and it's happening right now.
I'd just like to point out that their 3D printed object was only slightly more advanced than our 3D printed spaceship right here. Now, you mentioned Elon Musk's plan to get to Mars a few times. What do you think about that? And are you guys involved with that at all? Or does it change your plans at all now that they announced it?
Well, Elon has been quietly working on that plan for some time. We keep closely engaged with a lot of our peers in the aerospace world, including SpaceX. They have an amazing mission, an amazing team, and they have really brought rocket science into the 21st century with reusable boosters. And the team at Blue Origin has done the same. And we see a lot of other companies also working to transform getting things into space, like Virgin Galactic and Rocket Lab and other companies. So as Elon had just spoke to recently, he sees that really developing space is going to take multiple companies. It's going to take multiple technologies, and it's not a monopoly. And I think we've seen in his work in Tesla that, in terms of opening up the IP and encouraging the world to change over to electric cars, of course, Tesla wants to be a very profitable and leading company, but they can't be the only one. And it's the same thing in space. So our helping to refuel Elon's upper stages and helping to be a fuel source for the Mars Colony Transporter, helping to create destinations and industries and an economic base that allows us not only just to be in space, but to expand into space and to grow the world domestic product from $70 trillion to $700 trillion, because we're now no longer limited by being on this one planet for the rest of our existence. So we too also want to do our part to help create humanity to becoming a multiplanetary species. And it's been business economics which have helped accelerate the most exciting technologies, and we're happy to be doing our part alongside SpaceX and other innovators in the industry.
And just to wrap up, is there anything over the next few years that people should keep an eye out for? Any big projects, any big landmarks that you guys are going to attempt?
Well, we're very excited to get the Arctic 6 satellite into space in the next few months. Our team is working very, very hard on the final details of that. We'll have the world's first commercial thermographic sensor in space to be able to take pictures of the Earth both during the day and at night when the sun's not out. And this is helping prove out technology, which is going to be very important for identifying water on near-Earth asteroids. We're excited to grow into being an international company with a presence in Europe and to continue to really not only be a leader in aerospace technologies, but to keep up with what is changing all around us. And I think followers of PC Mag and folks who are watching this today really are kind of connoisseurs of the latest and greatest technology. And I like to remind people that a lot of the things that are making self-driving cars possible and actually inevitable are the very same things that are sending a robot out to an asteroid, something that a small private company in Redmond, Washington, that we can do that is made possible by all these other advances that we're seeing all around us. So we're happy to be doing our part. We're inspired by our mission, and also very happy to be inspiring others, and thank everyone for their support.
It's a very positive outlook for the future. Really hopeful. We love it. Chris, thank you so much. This has been an amazing conversation. I can go on for another 2 hours. I'm sure my bosses or anybody else working on staff, maybe not so much. So if you guys want to follow this at home, planetaryresources.com. You can follow, they're on Twitter. You are at Interplanetary.
I'm at Interplanetary. The company is at Planetary RCRCS. And of course, on Facebook, you can find us at Planetary Resources. And we'd like to share all the inner workings of what's going on and what it takes to build spaceships. And happy to share every step of our story as we work on building the 21st century that everyone imagined that it would be.
Chris, thank you so much. To anyone at home who participated, thank you. Thank you to Social Pete. If you like this, give us a like, give us a share. We really appreciate those. Check out some of our past interviews. They're great too. And as always, be good to each other. Peace.